Now the basic theory of IR spectroscopy is very simple, but you watch this very carefully. Now the molecule, if you consider a triatomic molecule having 3 atoms suppose, so these are the atoms bonded together with a bond. And according to first sentence, a molecule is not a rigid attachment. Means if it is rigid attachment, this bond distance or they are at fixed positions from each other. Very rigid, very tough, without any change, their position. But this is not the case. So the molecule is not a rigid atom, but bonds are flexible. Bonds are flexible means you can imagine as if these atoms are balls. These atoms are balls and they are joined together by using a spring. So the molecule is actually like a ball and spring model. And if you hold this molecule here and if you vibrate it, if you move this slightly, so you can observe there is continuous movement between these two atoms. These two atoms are actually changing their positions. So that is the meaning of flexible. So first of all, you try to understand, you can take any molecule, that molecule is not a rigid molecule, is not a fix. All atoms are not at exact position, means they are flexible, just like as if balls are attached with the ring. And if you consider that attachment, I mean ball attached with ring, you can imagine the flexibility of the bond. So that is the meaning of first sentence. So there is actually vibration continuously going on. If this is diatomic molecule, you can check this kind of vibration is continuously going on, and for that purpose it can take the energy from the surrounding, because vibration requires very less amount of energy. So this is the meaning of second sentence. So the molecule is not rigid and the molecule is always vibrating by different ways. So what are the different possible vibrations that are given here in the next point? So the molecular vibration, which vibrations are actually taking place in every molecule, that are given here. So basically there are two types of vibration. One is stretching vibration. Stretching means you can see here these two atoms are actually changing the positions. They are not exactly at the same positions. They are coming close, they are going away. Every time you imagine a ball and spring model. So this is called stretching. So the molecules are, in molecules, bonds are moving or bonds are coming close and going away. That is the meaning of stretching vibration. You can imagine or you can prepare the model and stretch it and then observe that kind of vibration. Bending means what? The position of atoms is fixed. That is another type. Only they are moving. They are moving without changing the internuclear distance. So that is called bending vibration. You can imagine the spring and ball model, and if you just heat it at one ball, you can imagine this kind of vibration or different kind of vibration where the atoms are not changing their position. Their distance between the two atoms, the distance between the two atoms is not changed in bending vibration. So actually for bending requires lesser energy as compared to stretching, because if you want to stretch that atom, we need more energy. Again, coming to the stretching vibration, there are two types of stretching vibration: symmetrical stretching and asymmetrical stretching. Symmetrical stretching means what? Both atoms are going away. I have considered here 3 atomic molecule. So these 2 atoms are actually going away, coming close. So both are going away, both are going away, both are coming close. That is the meaning of symmetrical stretching. So these 2 arrows means if both atoms are going away at a time and both atoms are coming close to the central atom at a time, So that is the meaning of symmetrical stretching. But this vibration is taking place along the bond axis. So this is the bond axis. So along the bond axis, this vibration is taking place. Symmetrical stretching. Now asymmetrical stretching means what? One atom going away from the central atom. At the same time, another atom coming close to the central atom. If it is going away, this is coming close. So that is the meaning of asymmetrical stretching. But this is also taking place along the bond axis. So this is the bond axis. So this is taking place along the bond axis. So stretching vibrations requires more energy. Stretching vibration require more energy. And there are two types of stretching vibration: symmetrical stretching and asymmetrical stretching. Now moving toward the bending vibration, which require less amount of energy as compared to stretching vibration. So there are four types of vibrations possible in the molecule: scissoring, rocking, wagging and twisting vibration. All these four are bending vibrations. Scissoring means just like our scissor. So both atoms are coming close. They are not moving away from the central atom or not coming close to the central atom. Only they are, that means this distance is fixed, but they are moving like a scissor. They are moving like a scissor. So this is a scissoring. So the bending type is scissoring. Another is rocking. Now the bond distance, this distance is fixed, but both atoms are going like this, moving toward the same side, moving toward the opposite side with respect to this atom, but this distance is not changed. So this is called rocking. So actually these two vibrations are taking place within a plane. If you consider this whiteboard as a plane, they are not going anywhere. They are not moving up. They are not moving back of this plane. So they are on the plane. So this scissoring and rocking taking place on the plane, you remember. Next is wagging. Wagging means what? This plus sign you can see. This distance is fixed, but plus sign means either they are moving up or they are moving down. So similarly you can use another direction. So if this is a plane, this is a plane, you can consider they both are going away, means behind the plane, or both are going up above the plane. Both are going below the plane, both are going above the plane. So that is the meaning of plus and minus. Up and down, up and below, above and below. So this is the meaning. So this is out of plane. So this vibration taking place out of plane, wagging. Now twisting means what? One bond, one atom going below, at the same time another is going up. So similarly another going up and next is going down the plane, up, down. So this is a twisting. So because of that, I have shown here plus means above, minus means below. So during next time, this will go up and this will go down. So these two are, means wagging and twisting vibrations are out of plane vibrations. So you remember all these 6 types of vibration. So symmetrical and asymmetrical, or this kind of vibrations, or bending vibration and stretching vibration, you should remember under the heading basic theory. Now we have just seen that there is continuously different kind of vibration taking place in the molecule, different types of bonds present in the molecule, different atomic size, or the different atoms are present in the molecule. So each and every factor is now responsible for the vibration of the molecule. There are as if different kinds of vibration possible in the molecule, and each vibration having its own frequency, that means its own energy. So I have shown here different vibrational energy levels of the molecule. Actually there is always some another change is also taking place, that is rotation rotation is also taking place, but for rotation requires less energy as compared to vibration, and for electronic excitation requires more energy as compared to vibration. So these are the energy levels you can see here. Vibrational energy levels you can see major gap, more gap as compared to rotational energy level. Only I have shown here in between V1 and V2. These are the rotational energy level. So this kind of rotational energy levels also present here in between each and every vibrational energy level. Now, when that molecule, which is always having vibrations or the different kinds of vibration for different types of bonds present in the molecule, or for you can say for functional group present in the molecule, if there is a continuous vibration, and then when we irradiate that molecule with IR radiation, infrared radiation from the said region which we have discussed in previous video, what happens? If that energy gap means delta E, this energy gap matches with the energy of this radiation, that is important, molecule will absorb that energy and will go to the excited state vibrational energy level. Means its vibration will move from one energy level to the another energy level, as if that vibration will go on. But if the molecule will go beyond that, probably that bond will break because there will be more vibration. Just like that, you can imagine if the molecule in lower vibrational energy level, its frequency is low, and when it is excited in the upper energy level, its frequency is more. And if you try to provide more energy, so it will even vibrate in very strongly, as if, or sometimes that bond will break. So these are the possibilities. So what is important? This energy must match with the energy of radiation, and that comes mostly from infrared region. And if that energy matches with, means this gap, this energy matches with the energy of infrared radiation, molecule absorbs that radiation and get excited to the another energy level, another vibrational energy level. And once it has happened, we get a peak, we get an absorption band, or this kind of transmission, this kind of percentage transmission is taken on this axis. And these are the wave number, which wave number is actually matching with this energy gap for different kinds of bonds. So because of that, we get different peaks, different IR peaks, IR absorption bands in the spectrum. Suppose this is observed at 35 centimeter inverse here. So this is for one kind of bond, say as if for OH, or this is around 300. So this is for CH stretching. So we get structural information. Or if it is around 1700, this bond, this band is around 17 to 1800. So that is for C double bond O stretching. So from this information, so we will discuss in next video, for different functional group, for different bonds, we get different bands, and we get valuable information from the IR spectrum. So what is important? So the IR, the whatever molecule you are going to scan in IR spectrophotometer, what happens then? Then you will get this kind of spectrum. This is the nature of IR spectrum, and whatever bonds are actually vibrating there, we get different IR bands. We get different IR bands, or different IR peaks, you can say here. This kind of spectrum, this is typical IR spectrum. You can imagine sometimes this will be very complicated, and we get valuable information regarding the structure of organic molecules. So this is the basic theory behind IR spectroscopy.